Today we will discuss the essential NumPy features for machine learning. So what is a NumPy? It is a Python numerical library built to work with multi-dimensional array, or what we call matrices. We can perform all sort of mathematical and logical operation on these matrices. It is much similar to Python list but gave much better performance as compared to list because it's built on top of C libraries. So let's get started. First we'll import the NumPy as NP. Then these next line will help us to print multiple outputs from the single cell. Let's move on and find the version of the NumPy we are using. So we are using 1.15.4 version. Your can be different than mine. So let's create our first array of size 10. By default, it will create the array of type float. We can specify the type of array we want by using dtype. For creating the matrices, we have to specify the number of rows and columns which we want in that. Next, we will again create the 0th array of size 10, but this time we will set the value of 5th element to 1. As like in Python, we have range function, here we have arrange function, which will make the array of elements between the range you specified. Line space works similarly, but here you can specify the number of elements you want in between that range. Next, we will see how we can reverse the array. It is much used when we have sorted type of array and we want to iterate in reverse order and other type of functions. For creating the complex number array, similarly as we created above by setting the dtype as int, here we can set it to complex for creating the complex type array. To know the type of elements stored in array, we can use .dtype, which will give us the data type of the array. Here int64 can store much bigger range than int32. We can also convert from 1D array to multidimensional array by using the reshape. But make sure the size of 1D array and the number of rows multiplied by number of columns should be same, otherwise we will get the error. It is very essential command used when we are converting the shape of matrices in neural networks. Next we will get the indices of non-zero elements from the array. .I is used to create the identity matrix. Here we have created the 3x3 identity matrix. Instead of creating the 0th array, we can also create the array and fill it with random values. So we can use np.random.random. This one used when we are initiating the weights of the neural network. We are initializing the weights of network randomly, then train the network to learn the right set of weights. If you don't get this reference, then no worry, I will explain this in upcoming videos. Next, we can also find the minimum, maximum and mean from the array by using min, max and mean function. For creating the 1th array, we can use np.ones, then we will pad this matrices with zeros. We will use the np.pad and specify the pad width and the value which will going to surround this matrices. This set of command is used in the CNN to pad the image with some constant values. Next, there are some results of expression involved nan and infinity. Type of values, nan represent not a number and inf means infinity. If you perform a calculation whose result can't be expressed as a number, then we will get nan as a result. Sometimes there's a need to get the part of the matrices instead of getting the full matrices. Then we can use these subscripts to slice this matrix. You can also get any particular column or row only as well as column 1 onward all the other columns from the matrices. For this you can use slicing also. You can do all type of mathematical operations on these matrices. We can multiply, add, subtract, divide, etc. However, you can see for multiplication array, size should be same. But for addition, we can match only the columns and the NumPy will broadcast that vector to create the similar size array for the addition. Dot product between two arrays are also very important in machine learning. While doing dot product, be sure the size should match. Like here, number of columns have matched with number of rows of other matrix. Otherwise, we will get some error. Now let's do Boolean type of all the elements and get only those which pass this comparison. So here I have set all the elements to -1, where condition of greater than 3 and less than equal to 8 are true. Next we will iterate through all the elements in the array using ND-iter method. Flatten is used to convert the multidimensional array to 1D array. This function mostly used in CNN network when we move from convolution layer to directly connected layers, so that time we use to flatten the layers. Let's move on to stacking two arrays. Here you can do horizontal stack, which means stack together side by side, or vertical stack, which means one upon the other. We can also do trigonometric type of function on the array, like find the sine or tan of the elements, as well as we can perform some statistical function like finding minimum, range or mean along the axis. We can do some date operation with NumPy, like getting the current date, then adding or subtracting some days to find the next day or previous day. Similarly, we can get all the dates in between some range of dates also. Creating the line space next and then get the inverse of the matrix. There is a way of finding the maximum value position in the array and replace that value with some other value. Just like enumerate in Python for tracking the number of iteration, NumPy have ND-enumerate, which do exactly the same thing. This next piece of code will do the normalization of the array by subtracting the mean from the matrix. This step have done oftentimes to normalize the matrix before input into the neural network. Swapping two rows in an array can be done by interchanging the index of the arrays. The rank of the matrix showing the maximum number of linearly independent columns or rows vector in the matrix. Linearly dependent means one row or column is linearly multiple of other row or column. Here we have used SVD to find the rank of a matrix. More on SVD we'll discuss on the sklearn video. Next is how we can find the n largest element from the array. For loading and saving the data in .npy or .txt format, we can use .save and .load respectively. Mostly we need to save array for the purpose of retrieval on later stages in the data processing pipeline. So these are some important NumPy functionality which is essential for the machine learning. If you don't get any of the reference in the video related to neural network, then bear with me. In the next couple of videos, I will clear all these doubts. Link to the notebook is in the description. You can download and play it with yourself. So thank you for having me. See you next time.